Out there, between Mars and Jupiter, lies a glittering ocean of stone and metal. Thousands of asteroids orbiting silently, older than Earth itself. And within them, more gold, platinum, and rare metals than our planet could ever hold. To some, they're lifeless rocks. To others, they're the key to humanity's next great leap. Welcome to the dawn of space mining. The bold idea that our future resources may not come from Earth, but from beyond it. The origins of the belt. Billions of years ago, while the solar system was still forming, the region between Mars and Jupiter tried, and failed, to become a planet. Jupiter's enormous gravity tore the process apart, scattering fragments of rock and metal that have been orbiting the Sun ever since. Today, we call this the asteroid belt, a vast, silent graveyard of a world that never was. But within that debris lies treasure: iron, nickel, platinum, even water ice, the raw materials of a spacefaring civilization. Most asteroids follow stable orbits, cosmic citizens moving in orderly paths around the Sun. But sometimes, a collision or a gravitational nudge from Jupiter can throw one off course. These wanderers, called rogue asteroids, drift unpredictably through space. Every so often, one crosses Earth's path, and history changes. The Chicxulub impact off the Yucatan Peninsula, today's Gulf of Mexico, about 66 million years ago, was indeed caused by an asteroid roughly 10 kilometers, 6 miles, wide. It released the energy of 10 billion Hiroshima bombs, triggering tsunamis, wildfires, and a planetary winter, wiping out 75% of life on Earth, including most dinosaurs. That crater, 150 kilometers wide, 93 miles, still lies buried under sediment today. Earth's resources are finite. Metals we rely on for technology, like platinum, nickel, and rare earth elements, are becoming harder to extract, more expensive, and environmentally destructive. But out there, orbiting in silence, are billions of tons of those same materials, untouched, unclaimed, waiting. One asteroid, just a kilometer wide, could hold more platinum than has ever been mined in human history. To harness that wealth, however, we need something extraordinary. Machines that can operate in space, learn from their environment, and make decisions on their own, powered not by human hands, but by artificial intelligence. That's where the real story begins. Every civilization runs on energy and materials. We build, we grow, we innovate, but everything we make comes from somewhere. And slowly, we're running out of the easy places to dig. Lithium for batteries, rare earth elements for electronics, platinum for clean energy. These are the veins that power our modern world. Yet they're getting harder to find and costlier to extract. Now imagine an asteroid the size of a mountain, one made almost entirely of nickel, iron, and platinum. NASA estimates that just a single one of these, called Psyche 16, could be worth more than $10,000 quadrillion. That's not just wealth, that's abundance. But here's the question: how do we reach them? Because mining in space isn't like mining on Earth. There are no humans in spacesuits swinging pickaxes. This is a job for AI. Autonomous spacecraft are already mapping asteroid fields using machine learning, scanning their shape, density, and mineral composition. AI-driven navigation systems help spacecraft predict orbital shifts years in advance. Drones, guided by smart algorithms, can identify where to drill, using spectral analysis to detect metal content from millions of miles away. AI doesn't get tired. It doesn't need oxygen. And in the cold, airless void of space, that's not just an advantage, it's survival. This isn't science fiction anymore. Private companies like Planetary Resources, Astroscale, and Transastra are developing early-stage systems for asteroid capture and resource extraction. NASA's Psyche mission, launching soon, aims to study and one day help mine the metallic heart of a long-dead planet. Every test flight, every robotic mission is part of a quiet race. Not for territory, but for technology. The nation or company that masters space mining first could redefine global economics forever. But when we start to take resources from the stars, who do they belong to? Under current international law, specifically the 1967 Outer Space Treaty, no country can claim ownership of celestial bodies. But private entities? That's a gray zone. Will space mining become the new gold rush? Or the new colonialism? Will we cooperate? Or compete, as we have so often done on Earth? AI can guide the ships, but only humans can decide where the moral boundaries lie. At the core of this revolution lies one idea: automation fueled by intelligence. Machine vision can read mineral spectra in milliseconds. Predictive algorithms can plan mining routes through orbiting debris fields. Swarm robotics, fleets of small autonomous miners, could extract materials without ever setting a human foot in space. Even recycling could happen in orbit, refining metals on site using solar energy harvested directly from the sun. AI makes this possible, coordinating thousands of complex tasks in perfect silence. We're witnessing the birth of the first machine workforce beyond Earth. But as we reach for the stars, perhaps the greater question is this: will we learn from our past before repeating it? If we treat space as just another place to exploit, then our future, no matter how advanced, will look much like our past. Endless disputes, wars, slow progress. That's what the tribal mentality brings. But if we approach it with humility, cooperation, and intelligence, human and artificial, then maybe, just maybe, we can build a future where prosperity no longer costs the planet. Space mining could be the bridge between survival and sustainability, if we have the wisdom to cross it wisely. The next age of exploration won't be fought over continents or oceans. It will unfold across the void, powered by machines we built and guided by dreams we've always had. AI will chart the stars. Humans will choose the path. And together, we might just learn that the greatest resources we've ever mined were our own imagination and curiosity. The stars are calling, not just to explore them, but to understand what they'll make of us. If you enjoyed this journey, hit subscribe and join us at AI and You, where intelligence meets imagination. Together, we'll explore the future, one idea, one video at a time.